College Algebra. This is the second part to Lesson 5.3. We're going to cover Cramer's rule today. And Cramer's rule is another way to solve systems of equations. So if you see a problem like example 6, normally you would do substitution or elimination to solve the system. But we're going to learn a new technique today called Cramer's rule. You probably already had this in Algebra 2. All right, what you need to do is you need to set up a set of determinants for x and for y, and I'll show you what all of that looks like with the notation from this system up here. So first of all, we're going to make what we call determinant d, and that's going to actually be the denominator of our fractions that we're going to set up for x and y. Determinant d is made up of all the coefficients on x and y. So if you look at your system here, you're going to see that the x's and y's line up and they're on one side of the equation with your constants on the other side. So I have my x terms lining up, my y terms lining up, then I've got these constants over here on the other side. Okay. What we're going to do for our denominator determinant is we're going to just put a of 1, a of 2, b of 1, b of 2. So it's the numbers that are in front of the x's stacked on top of each other, same with the numbers in front of the y's. We're going to find x, and that's going to be made up of the determinant for x over determinant d. You already know what determinant d looks like. It's a of 1, a of 2, b of 1, b of 2. Determinant x will be upstairs. It will be another determinant. Y is going to be d of y over d. And so we use that denominator determinant again. Okay. Now, pretend like you have here an x column and a y column. If you're going to find the elements for the determinant for x, the numerator's determinant, what you're going to do is, if you're finding x, these two constants are going to be replaced with c of 1 and c of 2. And those are the constants from right here. If I'm finding y, they're going to go right there. Then I just copy up the rest of what's underneath. So I bring up the column that's underneath, and that's how I set these up. From here, you find your determinants like you did yesterday. So c1 times b2 minus c2 times b1 over a1 b2 minus b1 a2. And then you go on from there. So it's easier to understand what to do here if we just apply it to a problem. So if the problem says to solve using Cramer's rule, I have to do it that way. I can't do substitution, I can't do elimination. However, you can always follow up with one of those two methods to check your answer. All right, the first thing you want to ask yourself is, do your x coefficients line up with your y coefficients, and are your constants on the other side of the equal sign? And they are. So what we're going to do is say x is a determinant over a determinant. Y is also a determinant over a determinant. So get yourself set up, give yourself plenty of room. You're going to come up with your denominator first. So I have a 4 and a 1, a 3 and a negative 2. Copy those. Okay. Then remember, you have the x column, then the y column. So if I'm solving for x, this 2 and 5 go right here. And if I'm solving for y, they go in the y column. Then you need to bring up what's underneath. Let me do those. My pen got really fat. And then we just carry on and finish it out. So we're going to go -4 minus 15. So I did this diagonal minus this one over -8 minus 3. 20 minus 2 over -8 minus 3. So -19 over -11 is 19 over 11. 18 over -11. And so the ordered pair is 19 over 11, -18 over 11. Now what you can do is you can plug those into the original equations to see if they check. You can solve the system another way to see if you get the same ordered pair. Let's try another one. I think I lost, oh, there it is. 64 is the next one I have for you. Okay, I will tell you that your textbook, especially when you get ready to do quizzes and tests, they like to really mess these problems up for you. So let's say, instead of seeing this problem, let's say they messed with you a little bit and they gave you that. And they gave you this. Before you ever start Cramer's rule, you have to make sure everything's lining up. Look right here. Do you have your x terms lining up? Do you have your y terms lining up? Do you have constants over here? You have to be really careful. So what we're going to do is switch things around and get everything lined up. So you would take this to the side and your 4 back over here. And if you clean up the order, you're going to have this original problem back, and then you're ready to go. So I just wanted to point that out to you, that sometimes the book, especially when we do quizzes and tests, they like to make you work just a little bit harder on these. They like to have you put them in the right order first before you get started. So you need to be super careful. Then we're going to go ahead and set up our determinants. Okay, so here's what we're going to do. We're going to, first of all, find our denominator. So 3, 2, 2, -1. Then we're going to find our numerator. Remember, this is your x column and your y column, and those constants go accordingly. They go in accordingly. Then you bring up whatever's underneath. And then we follow on, carry on with our arithmetic. So -4 times -1 is 4. Take away -10 over -3, take away 4. -15, take away -8. -3, take away 4. So we get the ordered pair -2, 1. Okay, now we're ready to move on. Okay, this is number 69. So I'm going to check it out first. Do I have my x's and y's lining up? I sure do. So I'm ready to go with Cramer's rule. Oops, I have a mistake here. There we go. Okay, So the bottom, 1.5, 2, 3, 4. And then the top. Let's see, I remember my x and my y, so I'm finding x, so the 5 and 3 go there. Bring up what's underneath. Okay, so let's see what we have here. 3 times 4.5 is what? You know what? I have made a mistake again, I think. I have these all backwards. I rely on you guys to catch me when I make silly mistakes and you're not here. Okay, the constants go for what I'm finding, so they need to go here. Sorry, I messed you up there. Here we go. Hopefully you caught that before I did. Okay, I'm going to stop here on this one because if you look, you're dividing by 0. You can't do that, so that means you have no solution. Okay, so dividing by 0 is not okay. Keep in mind though, if I had 0 over 11, that does equal 0. But 11 over 0 is going to be no solution. You can't divide by 0. But we need to kind of entertain what happens when we get 0 over 0. So if you had 2x plus 4y equals 1, and say negative 4x minus 8y equals negative 2, what happens when you do Cramer's rule on this problem? Let's just look at at x real quick. So dx over d. To negative 4, 4, negative 8. And then if I'm finding x, the constants go in first. And you would end up with negative 8 take away negative 8. Negative 8 take away, or negative 16. Take away negative 16. 0 over 0. So in this situation, you would have infinite solutions. And that means we're going to write the y arbitrary. I will show you that in our next video. I don't want to run over my 15-minute time limit.